Hi guys, welcome back to the channel. In this video we are going to discuss the MUX concept only, that is implementing of higher MUX with the help of lower MUXs. So let's see how to implement higher MUX. So main basic, these are the three basic multiplexers that we should know in conform, that is 2x1, 4x1 and 8x1. For our basic understanding, these are discussed in our previous video. So check out that video. I am giving that video in the description box, but if you know basic, so let's get forward. So total these are the four implementations that we are going to perform in this video. First we have to implement the 4x1 with the help of 3 2x1 MUXs. So next one 8x1 can be implemented with the help of 3 4x1 MUXs. Let's see how to do that. Next 8x1 can be implemented with the help of 2x1 MUXs, and 16x1 can be implemented with the 4x1 MUXs. So let's see all these four implementations one by one. So let's start with the first one. So for the implementation of 4x1 MUX, the bigger MUX, we need to have the smaller MUX. In that case, we need to have some 2x1 MUXs here. I took 2x1 MUXs 2. So join the two 2x1 MUXs in this format. So and you should add the two outputs of two 2x1 MUXs with the another 2x1 MUX. Finally, we are going to have the one output, that is Y. So as you are observing there, so for the first two 2x1 MUXs, we have the select line S0, and the next 2x1 we have the select line S1. So we can observe we have total the inputs as D0, D1 for the first 2x1 MUX and D2, D3 for the second 2x1 MUX, and the select lines are same for the first 2x1 MUX. And one more important thing, as the select line is same for the first two 2x1 MUXs, we can resample or we can connect both of the S0 lines, or we can connect both of the multiplexers as shown over there, and we can write S0 in the single position. That's to represent both of the multiplexers have the same select line. So how we can confirm this is the 4x1 MUX or not? So if you observe clearly the 4x1 MUX multiplexer here, so we have two select lines S1 and S0, and we have four input lines, that is from D0 to D3, and we have one output line. So in the same format, if you observe our circuit also with the help of two 2x1 MUXs, means 3 2x1 MUXs, we have four input lines, that is from D0 to D3. So we have two select lines S0 and S1, and we have one output Y. So whatever may be the inside blocks, we don't care, but the same logic can be performed with the help of the 3 2x1 MUXs. So we can able to perform. So that is the reason why we can say that we can perform 4x1 MUX with the help of 3 2x1 MUXs. So that is the reason that is known as the implementation. So if you observe for this implementation, we have the truth table for the 4x1 MUX, because as this behaves as the 4x1 MUX, we should take the truth table of 4x1 MUX. So if you observe 0 0 for D0, 0 1 for D1, 1 0 for D2, 1 1 for D3. If you want to know the implementation, how the implementation is done over here, so if you observe, I took an example that is in the position 1 1. So both S1 and S0 I took as 1 1. Observe clearly. After passing S0 S1 as 1 1, so we are going to follow normal steps for the 2x1 MUXs. So if you observe first two 2x1 MUXs, you can observe the second line, because that is the D1 in the first 2x1 multiplexer and the D3 in the second 2x1 multiplexer, because that is the rule of the multiplexer. We have to follow the positions. So after doing that, we are going to have D1 and D3 in the as two inputs for the third 2x1 MUX. So you can able to see in the second S1, the select line S1 have 1. So 1 means what? It will select the next line, the second line, that is D3. So the final output would be D3. So in the truth table also we can observe, if you take S1 S0 as 1 1, the final output would be D3. For the circuit diagram for the truth table also hence verified the circuit diagram is true. So let's take another example for more clarification, for more understanding. If you see the S1 and S0 as 0 1, if you take the second example, you are going to pass the S1 and S0 over there. So you can simply pass over there, no need to represent at all. So if you all represented also, no problem for your clarity. So I have passed directly, that is S1 and S0. After passing that, if you can observe the S1 is 1, sorry, that is S0 is 1. So as S0 is 1, you can observe there in the first two 2x1 MUXs, D1 is selected, in the second 2x1 the D3 is selected. After that, the third 2x1 MUX is the input, the select line is 0. So 0 means what? D1 will be selected. So final output would be D1. I hope you are understanding this one. So the next implementation in this is we have to implement 8 cross 1 MUX with the help of 4 cross 1 MUXs. So let's see that. So I took 4 cross 1 MUXs over here. So we can observe over there. So finally we have to implement 8 cross 1 MUX. So for that we took 4 cross 1 MUXs. So as you're seeing that total we have the first 4 cross 1 MUX have 4 inputs. The second 4 cross 1 MUX has another 4 inputs. So we can go from D0 to D7 simply. So first contains D0 to D3, second contains D4 to D7. So if you observe select lines also, both of the 4 cross 1 MUXs have the same select lines. If you observe, the first one contains the 1 output, the second one contains 2 output. As we are required the 8 cross 1 MUX, we have 8 inputs we got, but we need only 1 output. So for the 1 output, we are going to merge the 2 outputs with the help of the 2 cross 1 MUX, and we are going to have 1 output. That is our final output. If you observe, we have the select lines, the first two multiplexers, 4 cross 1 multiplexers have same select lines, that is S1 and S0. The second multiplexer, that is 2 cross 1 MUX, have another input, that is S2. That is the thing that we can say we have 3 input, means 3 select lines, that is S0, S1 and S2. So 3 select lines, 8 inputs and 1 output. So we can say that 8 cross 1 multiplexer is implemented. So as I said, explained, so this is equivalent to the 8 cross 1 multiplexer. The performance or the truth table or the thing that 8 cross 1 multiplexer can perform, the same things can be performed with this help of the 4 cross 1 MUXs or cascading of this circuit also. So if you observe the truth table of the 8 cross 1 MUX, so this is the truth table. I hope you know this truth table. You are going from 0 to 7, that is in the binary also, in the format of outputs also, that is from D0 to D7. For this understanding also, we are going to explain an example that if you take 1 0 1, that is S2 as 1, S1 as 0, S0 as 1, you are going to get output as D5. So remember this, that is output is D5. So let's apply all these S0s and S means the select lines into the circuit so that we can obtain the output. So let's see that. So as you are observing, I am applying the S2 and S1 in the first circuit. Sorry, that S0 and S1 I am going to apply in the first circuit. In the second box, the 2 cross 1, I am going to apply the S2, so that you can able to get the Y. So if you observe the first one, that is we are passing or we are having the select lines as 0 1. 0 1 means what? 1 in binary. So in binary, if you convert to decimal, that is 1. So 1 means what? D1. So we are going to select D1 in the first 4 cross 1 MUX, and we are going to select D5 in the second 4 cross 1 MUX according to the position. So after selecting that, we are going to pass as outputs. So for the second 2 cross 1 MUX, we are going to have inputs as D1 and D5. So the select line is 1 for the 2 cross 1 MUX. So 1 means what? We are going to select the next one according to the position, that is D5 is our final output. From the truth table also we can verify that. So I hope you understood this. So the next conversion is we have to obtain the 8 cross 1 MUX. So the same thing, the 8 cross 1 MUX only, but with the help of 2 cross 1 MUXs. So in the previous case we have saw with the help of 4 cross 1 MUX. In this case we are going to obtain with the help of 2 cross 1 MUXs. So if you observe here clearly, so we need total 8 inputs. For that we need to have total 4 2 cross 1 MUXs. For this implementation, you can see clearly over there, from the 4 multiplexers, 2 cross 1 multiplexers, we have total 4 outputs. So we can combine all 4 outputs with the 4 cross 1 multiplexer and we can produce one output. So if you observe, we are going from D0 to D7. Total we have 8 inputs and we have only one output Y. So we can say this is the 8 cross 1 multiplexer implementation. So you can also clearly see over there, we can cascade all 4 of them at a time, and with the help of only S0. For the first 4 2 cross 1 MUXs, we have only single select line, that is S0. For the second 4 cross 1 MUX, we have 2 select lines, that is S2 and S1. So if we consider an example 6, that is D6 in the 6th position. So if the corresponding the select lines are 1 1 0. So S2 S1 is 1 1 and S0 is 0. So as S0 is 0, we are going to select the top positions all from the 2 cross 1 MUXs all according to the position. So D0, D2, D4 and D6 will be selected as outputs. So for if you observe in the 4 cross 1 mux, those are all as inputs. So if you observe S2 S1, those are select lines, that is 1 1. So as that is 1 1, we are going to select the last one according to the select lines, that is as 4 cross 1 mux property. So that is 6. From the truth table also we can verify that is D6 as this is verified. So some might think, yes, this is the implementation of 2 cross 1 muxes only, why we are requiring the 4 cross 1 mux? So okay, I am replacing the 4 cross 1 with the help of 2 cross 1 mux cascaded circuit. So because we have already saw the implementation of 4 cross 1 mux with the help of 2 cross 1 muxes. So simply replace the 4 cross 1 mux with the help of the cascaded diagram that we have saw already, that thing with the help of the thing of 2 cross 1 mux. So after replacing that, we can see this is the full circuit diagram or cascaded thing of 2 cross 1 muxes only. The implementation of 8 cross 1 mux with the help of only 2 cross 1 muxes. I just did nothing, just replace the 4 cross 1 mux with the help of 2 cross 1 mux. So if you want simple explanation, if you can see the first two 2 cross 1 muxes can be cascaded with the help of the 2 cross 1 mux, because the outputs are 2, we can have the inputs as 2 and we can have one output. In the next 2 also we are going to connect with the 2 because we have 2 outputs, we can cascade with the help of 2 cross 1 mux. So the second two cross 1 muxes can have the one select line, that is S1. So after that also we are producing 2 outputs, we can cascade with the 2 cross 1 mux finally, and we can have select line as S2, and we can have the one output, that is Y output. So this is the thing. So for this also the implementation would be the same. If you consider that D3, that is S2, S1, S0 as select lines, that is 0, 1, 1, you are going to pass the select lines as I am showing there. So as S0 is 1, you are going to select all the down positions according to the 2 cross 1 multiplexer rules in the positions. So D1, D3, D5, D7 will be gone as output to the next step. So in the next step you can see over there the 2 multiplexers, the 2 cross 1 multiplexers, you are going to have S1 as 1, the select line. So according to the position also we are going to select or D3, D7 as the next outputs. So in the next outputs we are going to pass D3 and D7. So if you can see the last multiplexer, that is the S2, the select line is, so that is 0. So that as that is 0, we are going to select the top one according to the position, that is D3. So you can observe the final output is D3. You can also clarify with the help of the truth table also. So this is the final thing. I hope you are understanding. So the final thing is we are going to convert, or we are going to implement the 16 cross 1 mux with the help of 4 cross 1 muxes. As one 4 cross 1 mux contain 4 inputs, so we are going to have 16 inputs. For that we are going to have 4 cross 1 muxes. So as I am show there, we need to connect all cascaded like that further with the help of only 2 select lines, that is S1 and S0. So as we are getting 4 outputs, so you can also see we have total 16 outputs going from D0 to D15. As we are producing 4 outputs, we need to cascade with the help of the single 4 cross 1 mux. So you can observe there in the second 4 cross 1 mux we need to have 2 select lines, that is S3 and S2. Finally we are getting output Y. You can see clearly and we can compare with the previous examples also. So if you want the 4 cross 1 mux to be implemented with the help of 2 cross 1 mux, so you can do simply like that, because we have already saw the explanation of 4 cross 1 mux with the help of 2 cross 1 mux. So if you see clearly over there, I have just did nothing. I have replaced the 4 cross 1 mux with the help of the cascaded diagram of 2 cross 1 mux. So if you observe that for the first outputs of 4 cross 1 muxes can be cascaded with the help of the first 2 cross 1 mux. In the same way the second thing also, the select line would be S2 and the second the 2 outputs would be passed to the select line S3, the 2 cross 1 mux. Finally we are going to have output as Y. So this and the 16 cross 1 mux, the implementation would be the same, the output would be same, the truth table would be same, but the circuit diagram vary, that's it. So finally I hope you understood this video. Thanks for watching up to now.